anything that is considered alive is an observer, right? You might
In a sense,
disagree, like,
yeah.
oh, plants aren't observers. Well, they observe somewhat
In
what's
a
going
sense.
on
In a
in a
sense, yeah.
sense. And so what I'm saying is that physics as we know it depends purely on who is observing.
Observation, true.
Because, the fact that we have eyes will obviously affect how we measure things. AKA, you wouldn't be able to measure the brightness of stars if you didn't have eyes. Or maybe, I don't know, maybe there's some type of weird tool that you can conjure up. But anyways,
Okay.
what I'm trying to say is that being an observer in our universe, in our space-time universe, is what shapes our study of physics. And physics is, an observational science. You look at things and you try to describe them, right?
If you
You
think about it,
observe
though,
acceleration.
all
Yeah,
sciences to a certain extent are observational. Like
yeah,
chemistry, you're
yeah.
observing, when you mix two chemicals together or
Of
something, what
course,
happens. Biology, under microscopes, you're looking at certain cells and certain reactions. So at the end of the day, I think all sciences, even though we are focusing on the physics of it right now, like all sciences are in some way highly observational. And without that observer there, like none of them can really truly be ever written, right? Because
yeah,
like
of
the
course,
entire reason for how they were written was with observers who observed certain effects, right? And
of
those
course.
effects is what we now know as physics and chemistry and biology.
Yeah, and in a sense, there is no distinction between physics, chemistry, and biology, right? Because at some point, what you study in physics borders what you study
I
in
mean,
chemistry,
chemistry,
and what you
and then
study in chemistry borders what you study in biology. So it's
true.
all kind of this continuous spectrum of
Because physics is kind of like a
just,
smaller version of chem, and chem is kind of like smaller as in more precise. Like
well,
more like we're kind of zooming in, right? Like you see the human body, it's okay, it's biology. You go to your organs, it's biology. You go deeper into how they're like energy transportation, that's chemistry, like
yeah.
bordering chemistry, biology. You go even deeper into like I don't know, quantum entanglement or
Mm,
quantum tunneling in your body, which
yeah.
definitely occurs. That's where you borderline physics, right? So it's
The
kind of all
reason why
zoom
I
in.
prefer physics is
Okay, let's hear
because
it.
yeah, we it's kind of like a smaller version of chemistry slash biology, but at the same time, it's everything. Like in physics, you study every scale. You study the absolutely microscopic subatomic scale, and you also study the human scale, right? Like the motion
True.
of objects and the gravitational pull and forces and all that stuff. And then also up to the cosmological scale, where you study the most massive and the largest distance-wise objects that exist in the universe. And so it's like you get a piece of every single kind of
It's kind of
scale.
yeah.
Like,
I think that's the biggest advantage because like in physics you have the quantum realm and you have like the cosmological realm, and those
yeah.
are complete polar opposites, yet
Hmm.
still exist in the same field, which I think is a pretty interesting phenomenon of it.